The broadcast is now starting. All attendees are in listen-only mode.
Hello and good morning or afternoon or good night, everybody. We're broadcasting here from the World Energy and Meteorology Council headquarters in Norwich. And we are going to talk about the first webinar and the C3S Energy Operational Service, which is run under the Copernicus Climate Change Service. So this is the first webinar run by the C3S Energy team. And I'm going to give you a bit of introduction about what C3S Energy is. So the C3S Energy builds on two precursors. There were two proof of concept contracts, one called Clean for Energy, which you see some of the output on the left, and the other one was the European Climatic Energy Mixes, shown on the right. And you can see the links there if you want to access those at the moment. As you can see at the bottom, this is the timeline for C3S Energy. So we started on the 1st of May 2018, and we're now halfway through the 2-year contract. And we are now in the phase of finalizing some of the products that are being taken from some of those provided by the previous two proof of concepts and turning them into operation. So it's been a lot of work refining and turning all this output in operation, and this is done by a consortium of 6 partners. The lead contractor is the World Energy Meteorology Council, and the partners are the CA in France, Meteor France, Électricité de France, and Met Office, UK, and then Armin, again, France. So a strong consortium here to produce this service. And the rationale for the energy operational contract, is that we are developing this service with and for the energy industry stakeholders. This means that not just capacity factors are calculated, but we also spend quite a lot of time collecting energy data and making sure that we provide also the data in terms of energy units, because this is useful for example, when we want to compare demand with supply. We also want to continue bridging the communication gap between the climate and energy communities, and involve also additional people in the conversation, spanning policymakers, strategists, and also students, high school students or university level. We're also strengthening the knowledge of climate scientists interested in energy issues, so that we can build a new and strengthen the knowledge base for people coming from climate science and producing the services for energy. What we provide as a service are 3 streams. The first one is for the historical record, 79 to present, and this is based on the reanalysis era 5. Then we'll have a seasonal forecast on an operational basis, and they will have 3 systems, CNWF, Meteor France, and Met Office, and then projections that are based on Eurocordex 12 models. And the domain, I should also add at this stage, is just Europe, and that's the remit of the contract. This may change in the future, but not for the time being. We got climate indicators that are relevant for energy, like temperature, precipitation, solar radiation, wind speed, and mean sea level pressure, and a few others, and energy indicators like electricity demand, hydropower, both run-of-river and reservoir, solar power, just PV, and wind power, both on and offshore. This is a bit of a schematic, so we go all the way from the original climate data, we look at the quality of the data, and then convert them into energy, and finally produce something that is visible onto a visual demonstrator, which is being now rebranded and redesigned and redeveloped. So it's not available yet, but watch this space. So house rules for this webinar. We'll have one presentation today, followed by Q&A. You will be able to type your questions in the tab, and then we'll read the questions at the end and reply to them. The presenter will do that. The webinar is recorded and will be available online sometime after the webinar. And the agenda for today is the following. So as I said, one presentation. The presentation is using the climate data store to obtain and prepare climate data for climate and energy indicators. The speaker is Luc Sanger at World Energy Meteorology Council, and he's a data engineer with us. Then we'll have a question and answer session, and I'm the webinar chair, as you can see at the bottom. Okay, so we're ready now to switch over to Luc, who's going to walk us through the webinar presentation. Over to you, Luc. Thank you.
Can you see my screen? Hi, welcome to the first C3S Energy webinar, a collaboration between C3S and World Energy and Meteorology Council. The topic for this first introductory webinar is using the climate data store to obtain and prepare climate data for energy and climate indicators. My name is Luc Sanger, and I am a data engineer at World Energy and Meteorology Council here in the UK, or WEMC for short. Generally, my roles involve retrieving data, checking data, cleaning data, archiving, warehousing, distributing, creating pipelines for data. So it's very much a data-based role. In the case of the C3S Energy project, data for creating climate and energy indicators come from various sources. But in this webinar, I'm going to focus on how we use the climate data store to obtain and prepare climate data for climate and energy indicators. And my email is on here. If anyone wants to contact me about anything related to this, they can. And also all my code pertaining to the C3S Energy project is uploaded to my GitHub page. So I would encourage anyone who is interested in looking at the code to link up on there and help contribute to that. That'd be great, thanks. So this introductory webinar is the first in a series from C3S Energy. And we're going to look at accessing the climate data store and the toolbox using the CDS API versus the toolbox for downloading climate data sets, and looking at the advantages of either of those and the suitability for your needs. Checking NetCDF files for anomalies and quick visuals, issues with data from this climate data store from CDS, and functionality of the toolbox. This is ones that I've come across in the project. Using an offline NUTS method. NUTS is a type of area shape files that we've been using in the project to map data to countries and regions. And we've created a method to do this as complementary to the toolbox. And then we'll sum up and have a quick look at the C3S Energy user learning platform. So, as said before, this is the first in a new series of webinars to highlight the work carried out so far with C3S Energy. And on a kind of bi-monthly basis, we'll be running them. From May the 22nd, we'll be looking at energy models, demand, hydro and solar. July the 5th will be seasonal forecasting. In September, we'll be looking at climate and energy projections. And October, November, we'll be looking at case studies related to the project. So it should be a very interesting series of webinars. So to start with, to access the CDS and Toolbox, you need to register for a free account. Some of you may have done this, or if you haven't done so, it's very simple at the CDS website. The one thing you need to know is when you create an account, you need to get a registration key, and this is added to your computer's bash file, which is there's clear instruction on how to do it, but it does take a little bit of using the command line to add that. But instructions are on the Copernicus website how to do that. And once you're registered, logged in, you can click on the Datasets tab to browse the climate data store. It's all open source and free to use, and anyone can create an account there. So in this is the kind of climate data store view where you can select your variable and years for your data set. So you can customize and choose your data how you like. In this example, I'm selecting total precipitation as my variable and a year's worth of data. So you have 2018 and all the months there. And generally 1 year of ERA5 data, this is ERA5, hourly resolution for a year for a European region comes in about 1 gig, just under 1 gig. So for post-processing, such as applying country averages and so on, I found it works best using data sets broken down into gigabyte or less chunks. Because one thing I've come across is using much larger data sets, say 10 years worth in one, can increase the risk of RAM or processor issues. And if something crashes in the process or there's data missing, there's obviously more to rerun if you need to. So I found in this particular project, using data sets that are a gig or less has been the kind of optimal amount in my experience. So once you have the variable, date and format field selected you want, you can click Show Toolbox Request, and it will pop up with some code here, some Python code, and this very simply can be copied and pasted into the toolbox. So the toolbox, you just click on the Toolbox tab and you get a kind of console window. Paste it in there, click Run, and you must leave that window open and wait for the download link to retrieve the file. So if you're retrieving 1 year of data, of ERA5 data as interest, then this is quite a good way to do that. It's very easy, relatively quick, but it's not necessarily optimized for automated operations and looped retrievals and so on. So if you're looking for just a particular data set, this is an excellent way to do it. And the other option, if we go back, you can show Toolbox request. You can also show API request. And that's if you want to access the climate data store via their C3S API. So I've got a quick comparison here between the two, as we had to decide which method was best for our needs. As you can see, both the API and the Toolbox have their advantages. It's a matter of choosing the appropriate method for your task. In the case of C3S Energy, the goal is to produce an automated system which will create climate and energy indicators that will ultimately be available for users via the C3S itself. So in our case, excuse me, using the API is preferred approach for obtaining the data. So using the API via Python script, it can be run in the background, whereas on the Toolbox, you need to run it within the browser. An advantage for the Toolbox is it's very visual and very easy and easily accessible if you're not a programmer, for example, or you just need to access the data for some application, then it's very simple to do so. An advantage from the API is that it could be run from a remote server, which is how we intend to use it and how we are using it. And on the Toolbox side, another advantage is you can operate and perform lots of useful data analytics tasks and retrievals from within the Toolbox itself. So remaining within the climate data store ecosystem is definitely an advantage, and you can perform plots and all sorts of things from within the Toolbox. So I think as an individual user, Toolbox is an extremely useful tool, and for, in our case, creating an operational automated system, the API is suited to our needs. So once you've got your data, and in this example, I mean, the two main data types available on the climate data store are GRIB and NetCDF. And for our system, we're using NetCDF files. So once you've got your data via the Toolbox or via the API, in my day-to-day tasks, I have to check this data before passing it on to climate scientists to perform their modeling and so on. So we're using Python for most of our code, and my first kind of choice would have been to use Python and matplotlib for checking the data, but this I found wasn't really ideal for checking data sets very quickly, because matplotlib has, if anyone's used it, has many options for plotting, and it takes actually a little while to set up and set all your parameters and so on. And so for simply checking a data set, it's a bit long-winded. Another tool you can use for checking the NetCDF files for consistency and so on is CDO and Climate Data Operators, I think it's called, is a command line tool, but that does kind of assume familiarity with the command line, and it's very useful. But yeah, if you're not comfortable with that, it may not be the ideal tool. So the tool I find I use a lot for very quick checks of NetCDF files is Panoply, which is a free tool. It's very quick for just opening and plotting NetCDF data and slicing the array, looking through time steps and so on. And it's a free tool from the NASA website, and there's a link there. And really you can double click on a NetCDF file, it'll open in Panoply, and you can check the time series, look for anomalies, check the data, it looks how you expect, visually, and also you can look at the data set itself. Because if anyone's ever tried to look at a NetCDF file in Excel or something, it doesn't really work. So you do need a specific tool for the task. So I use Panoply as a quick visual check to see if the data is how I expect in terms of the amount of steps. So it's hourly data. In a year, I'd expect 8,000 odd steps. And whether the variable has the correct units and so on. So this is a quick view of a NetCDF file obtained from the climate data store. I've just opened it in Panoply, and within 30 seconds, I've got the variable name at the top, which is air temperature. I think it's 2 meter air temperature, this one. And the data set, the ERA5 data set I downloaded I specified for the European domain, and it's just showing the European domain, so I know that's correct. The units are in Kelvin, which is as I would expect as well with the file. I've got a little plot there in color so I can kind of see what's going on. And finally, it's 1 day's worth of data, and I can see the time at the bottom there has 24 steps, so 24 hours. So as a quick check, that for 1 day of data, that tells me that it's kind of in the right ballpark. It's possible other anomalies may exist when the data is passed on or looked at by someone else, but I know from this, at least, that the data that I've downloaded is as I would expect. So that's how I would quickly check some data I've downloaded from the CDS. In terms of our role creating an operational system for C3S Energy, I've used Python to create a small script to check if the file names are correct. So we can check visually using Panoply whether it looks okay, but in terms of our operational system, we need to find a way to make everything automated eventually, so we don't have to open things like Panoply and we don't have to check things by hand. So the idea is to write automated scripts to do this for us. And in keeping with the Toolbox theme of Python, we're using Python as well, so it complements the Toolbox and the Climate Data Store. So this is about as technical as the webinar will get, so don't be put off with the code just now. It's just for 1 slide. So I'm using 2 bits of code, or 1 script and 1 JSON file to check a file name consistency. So what we have on the left here, the kind of multicolored code is Python, and what this does is it checks a string, a series of letters and numbers, to see if they match our conventions for C3S Energy. And on the right-hand side, you can see a little snapshot of some of the options that we have given ourselves for a file name. So it might be historical, a seasonal, or projection data stream. So we can select one of those, HS or P. And then we've got the generation of data. So the one we've been looking at from the Climate Data Store is ERA5. But as I mentioned before, there is data from other sources involved in creating climate and energy indicators, and they can be selected here as well, like Eurocordex, etc. Where their data originates, so ECMWF, Media France, Met Office, etc. Any modeling applied, and so on. So these are, so we can ensure that the file name best describes what's in the file. And then this code will check the file and produce a quick output to see if all the elements are present and correct. So this, I said that was the only page of code, but this is kind of 2 pages really. So this example is an example of the code conventions that we're using in our operational system. So it has 20 fields. I won't go through each one, but what you can see here is the script has checked this file, checked all the elements within the file, and given a tick if it meets the ones as defined in the list on the right there. So we can see yes, 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 it looks good. And at the bottom, the message, there are 20 of 20 required elements in the file name. So if I'd incorrectly entered some parts of this, it would show some errors there. So there are 2 ways that we use to check data from the climate data store. So there's the kind of manual method and the automated methods that we're working towards in creating the operational system. So issues with data from the climate data store and the toolbox that I've come across during the project so far is, it's not an issue, but in general, on the whole, the data from the climate data store is of extremely high quality. It has metadata and everything all present and correct. And it's very useful in, you can see where it comes from, exactly what the data pertains and so on. But like with any large, big data, large volumes of data, there may be inconsistencies present. And the climate data store itself is still in beta, or beta version. So, so it's important in my role, and I think to anyone using a beta system, is to report any issues that you may come across back to ECMWF, and there's a feedback button for that. And they've been extremely responsive to requests and bugs and things that there hasn't been many, but any that has arisen and reported, they've acted upon. So it's like with any kind of open source project, it kind of relies on users to help improve it as well. So I would suggest using the feedback if you find anything. So here's one example we came across with wind data, and we were using 10 meter and 100 meter wind data for our climate and energy indicators. And from the climate data store, we downloaded both forecast and analysis wind data. And on our initial checks, it looks okay, but from one of our colleagues in France found in one small area of France, there was a daily drop in the wind speed, something you might not recognize looking at the data initially, but which comes up later on in the stream, in post-processing, for example, where someone's applying some models and they come across an anomaly. So every day they're with the analysis wind data, you can see here there's around 9 AM, there is a sudden drop in wind speed, and this happened every day. So it didn't look natural. And then when compared with the forecast data, you can see there's a distinct difference, a distinct drop around sort of 9 AM. So this is an averaged year over 2008 in this area of France, where the issue, northwest France, where the issue was picked up. And so our conclusion was to use the analysis data instead, and we reported this back to ECMWF, who have acted upon the issue. So it's it goes to show that that anomalies and issues can show up later down the chain rather than just in the retrieval itself. Issues with the data from the CDS and functionality of the toolbox. Okay, so our demonstrator, which you saw in the introduction earlier, relies on providing data at country level and at regional level. So our initial goal was to use the toolbox to create our application, but the area averaging, also known as NUTS, area averaging wasn't working on the toolbox. So this led to us developing a complementary offline approach, which can run alongside the toolbox, also uses Python, etc., but includes the NUTS functionality, which is currently missing from the toolbox. This feature is being worked on by ECMWF, so it should be implemented soon. So our solution is an interim solution using Python, and the packages I chose for this task is one called Iris, developed by the Met Office for reading in the NetCDF files, and another open source package called GeoPandas for loading in the NUTS shape files. And we're currently running this on a virtual machine at ECMWF. So comparing the output of our NUTS averaging to the toolbox output, initially the NUTS averaging was working on the toolbox, but we reported it as being slightly different to our output. So it's kind of being worked on at the moment to bring them closer. But looking visually, they look almost identical from our offline approach using Python to the toolbox initial NUTS functionality. But look at when we examined much closer, we could see that they're ever so slightly off in when we compared from one data to another. So you can see one overlay to the other. There is a kind of 0.404 difference in some parts between the toolbox output and our offline output. So again, this was a good opportunity to feed back to ECMWF and help improve the system. So in terms of retrieving data from the climate data store, my role really is to concentrate on checking data both pre and post processing, reporting any anomalies and things back to ECMWF to help improve the climate data store. As said before, it's still a beta. And yeah, please sign up for future webinars in our series. Next one is in May, sorry. And we have a blog on all our work, Python code work and so on, tech work towards this project is on our website here. And linked to that are all the code is on GitHub. And finally, everything we're doing in terms of user support, webinars, blogs, seminars, educational activities, and so on will be collated and presented on the new C3S user learning services. It's the learning platform. And this is part of Climate Data Store and will offer training in all aspects of using the Climate Data Store. Okay, so that's it from me. I hope you found that useful. And once again, it was very much an introductory webinar to the C3S Energy project. Thanks a lot.
Okay, thank you very much, Luke, for the clear presentation and walking us through all the technical details. I mean, there's much more, of course, that Luke has encountered and is doing, but this is just to give you a flavor of what an operational activity entails, and I hope that's useful because I know several of you use data all the time, and little suggestions like using the correct file names and things like that can help a lot when you repeat operations over and over. So if there's any questions, please type them on your panel. We can also get questions later through emails, maybe directly to Luke or the general email info@webcouncil.org. We are also going to upload the presentation and recorded presentation and webinar on website. Will communicate to all people registered where they can find the registration, the recording afterwards. So we have many attendees. So thank you very much for connecting. We'll wait a couple of minutes to see if we get any specific questions. I received a few which we can address offline. So as Luke also was saying, I just wanted to remind you about the next. The next webinar is coming up quite soon. So 22nd of May, it's going to be on the energy models. So in the C3S energy operational service, we take climate data and convert them into the energy indicators as we presented before. So all this will be discussed at the next webinar on the 22nd of May, and we'll send the notification so you can register for that. And then the 5th of July on seasonal forecast for energy, focusing on things like bias adjustment and forecast skill, and also how we convert the seasonal forecast into energy indicators on an operational basis. So with this, I would like to thank you for your attention, and I hope to see you at the next webinar. Thank you very much. Have a great Easter period. Bye-bye now.